Okay, here it is. Question number 9. So this is I'm continue from example number 9 in lesson number 2.4. This is on conditional probability. Remember last time we learned what is probability of A and B, or probability of A when B occurred is probability of A and B divided by probability of B. This is what is the lesson about, which we can also write, use this is called conditional probability. And if you multiply probability of B both sides, you also get same thing. So this becomes probability of B times probability of A when B occurred. Now let's see how do we use this. In this case, a marble contains 10, a jar contains 10 marbles, 7 black and 3 white. Now, I'll take off this and make this as red. That means if this is a jar, and this jar contains 7 marbles, 1, 2, 3, 4, 5, 6, and 7. And it also contains three reds. These are red. And there are 7 blacks. So 7 blacks. And even though I take time, I just like to show that to understand the visual. And when you pull out two, because this question says you pick up 2 marbles without replacement. This basically means the order is very important. Order matters. So the question is, if I pull out 2 marbles, one, and then you pull out another one. So the question is asking, what is the probability that both are going to be played? So you can do this in different ways. I'll show two ways. One is mm, we can use probability that first black and so first one is black, or instead of that I can say black B1. It means if I write B1, you may get confused. So this is the right way, and B2. Okay, so this means first black and second black. So now we can use our regular formula. This one, see, this one, the multiplication rule of probability says that means probability that the first one is black times, then we can write probability that the second one is black when you already know the first one is black. See, this is what that multiplication rule of probability says. Now the first one is black. That means when you pull out the first, so you're pulling out of this the total. So the total marbles in the bag there are 7 plus 3, which is there are 10 marbles. So from 10 marbles uh, you're picking up um, black. So the black itself there are 7 marbles. See? So then you have outcomes favorable for the first one to be black, means there are 7 of them, so it has become 7 out of 10. Once that is done, one of the marble is gone. Let's see, this marble that is this marble is already here, so it's already gone. So that means you don't have a black marble, so you're left with 6 marble. So that means your next one will be, this is what it is. Since you already know this part is, you already know the first one is black. So that means how many total marbles are remaining inside. And you can see now there are no more 10. There will be, one is gone. So one is gone means there are 9 marbles. So this will be 9. So out of 9, you want to pick a black one. So there are black. Since one is already gone, there are 6 of them. So to get 6. So your answer is 7 times 6 is 42, and divide by 10 times 90. And if you do little maths there, you get 0.47. So this will be 0.4. This is one way to do this. So with So can we do this without conditional probability? I mean, multiplication rule of probability? Yes. This is what you did even in the earlier classes without knowing this formula, and where you just use your common sense and get the answer. But question is there another way to do this? And another way to do is using permutation. Now, what is permutation means? Since you are picking two marbles from the jar, this is the jar, right? So what are the total possible outcomes? Picking two balls. Well, how many different ways can you pull out? What are the total number of permutation possible to have two marbles to be picked up? So the two marbles to be picked up is, since you have 10, so that should be 10 P2. And since the numerator is number of outcomes, so you want two black. So both blacks, if both blacks basically means from 7 you pick 2. Now you can use calculator, get the answer same, but I will use without calculator. This basically means 7 factorial divided by 7 minus 2, and same thing 10 factorial divided by 10 minus 2. Okay, so which is 7 minus 2 will be 5 factorial. So this I can write 7 6 times, and the bottom is 7 minus 2 is 5 factorial. So you know why I wrote this until 5. And this will be 10 times 9 divided by 8. So here this is 8 factorial. So this is 8 factorial. So we can cross out the 8 factorial, and you can cross out this. What I left is, so what I left is 7 times 6 divide by 10 times 9, that is 42 divided by 90, and you get the same answer, 0. So this is another way to do using permutation. Now I like to show one more way to do is also using. Let me clean this up. You could also use using when you from the jar, when you pull out a marble, that marble could be so in this here I'm gonna show another third strategy to use the same problem. So there is a jar. In this jar, you can see there are 7 black marbles and 3 red. So the question is, we can do the visual. So let's see, this is the starting point. And when I pull a marble, so this is, it could be, it could be black, or it could be the first one. The first one could be black, so I'm putting 1, or the second one is uh, black, or the first one could be also red here. So I'll put the first one is red. So if the first one is red, black, then the second one will be, could be black, or the second one could be red. So I'll put red. If the first one is red, the second one could be red too, or it could be black. The second one could be black. So these are all. So we want to know the answer. So for this, I can write probability that it is black first and this way. This is probability that it is black first and red second. This is probability red first and red second. And the third one is probability that it is red first and black. So for this to get this each one of them, we say, okay, what is the chances that the first one is black? So you have 7 black here. So this will be 7 out of 10. So, but when you go to the second option, you'll be out of 9 because one marble is gone. And you want to have black, second also black. So out of 7, one marble is gone. So there will be 6 remaining. So it will be 6. So if you multiply these by fundamental counting principle, you can say 7 times 6 is 7. So if you multiply the numerators, so or you can write 7 over 10 times 6 over 9, which is, if you use the calculator, you get 0.47. And that's what we got earlier, remember? Or you could do this way. First one is black and the second one is red. That means uh, if the first one is black, there are 3 red remaining. So these are the 3 red. 1, 2. So this will be 3 out of 9, correct? So this answer will be 7 out of 10 times 3 out of 9. So that will be 21 out of, or you can directly write the answer using the calculator. So you get 0.23. Okay, now here the first one could be red. That means there are 3 red. So this will be 3 out of 10. And then the second one is red will be 2 out of 9 because one red is already gone and the denominator is 9 because one less. Oh, so this will be, when you multiply this two, it will be 3 out of 10 times 2 out of 9, and that will be 6, will be 0.07. And finally, you have first red and the second black. So the first one is red, black, all 7 out of 9. Uh, so, and then you multiply this two, so it is 3 out of 10. So the first one is red, and then second one is out of 9. So you're picking all 7 black. Sorry, red. Sorry, black, right? So this will be 21 over, which is 0.2 and 3. So the question was, so using this chart also we could answer this question. If you see, the first question was asked, what is the probability that both black, and the second one is black, and you got the answer there, which we already did. Of course, I showed we already got this 0.47. I think the second question is probability. It says exactly one marble is black. Exactly one marble is, so exactly one marble is black, right? So that means it could be the first one is black, the second one is red, or it could be first one is red, and the second one is black. So first black and this will be right here, which is 0.23, and this will be right here, which is again 0. So it is like 2 times. So you get 0.46. So this takes care of the answer for the second part. And the last question is, and one more I wanted to also show here is, I know you don't have to do this, but I like to show that will be some of you would like to understand the whole concept. Exactly one marble basically means this is understood, right? Supposing we had not done the whole visuals here and we got this answer directly. Suppose we did not have to do without. Can we do without this? Yes. So first one, so so probability that of course it could be first black, and uh, the second one red. So there are two cases. It's option, or it could have been probability First one is red, and the second one is black. So this could be written using also, if you had not to do this, one is using directly the conditional probability, or you could also do this mm, using permutation. That means you are picking 10p2. So you are using actually 10p2 here also. But then the top part is, it is like we have 7 black, so it is 7p. You're picking one here, and then you're choosing red, so it is 3p1. Or it is R1 first, means the red first. It means there are 3p1 times or 7p2. So this is another way to do this and use the calculator get the answer. But eventually, what is so eventually this basically means, so this basically means it is 7p1. If I have npr is all np1, sorry, np1 is always, if you are picking one, there will be n ways. So this is direct answer. So this is like 7 times 3, and the down one, remember, can be written as 10 times 9 because there is 2. You can all the way do that. And the same thing here, it is 3 times 7. So it is like 10 times 9. And you can see that this 7 and 3 is the same. So basically it is 21, or it is 2 times 7 times 3 divided by 90 is here. Both the denominators are same, so you can write it like that. And use the calculator, get the answer. So the understanding piece is here, why this is 2 here. Okay, the last question is, so the last question is C part. If you see, check your paper, there's a, what is, so the question is, the last question is asking you probability of drawing at least one black marble. So what is the probability of at least, at least one? So this answer is directly same as one. We can use uh, complement rule. It means one minus at least one basically means you could just add this one, you could add this one and this piece. All this we could add. So you could add those, this, 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 and this. But I'm gonna use this one. One minus probability is no black, or both white. I mean black, red. So instead of this, we could write no black basically means both both red. So this will be one minus and both red. So this is 0. This one 0.07, which is 0.93. You get the answer. But you may say, hey, what about this if we have not done all this? So I'm gonna directly also show that if it is probability is at least probability of probability of at least one black, right? Is same. I wrote it as one minus probability of uh, one minus both red. So if you had not done the work, then you could do like this: one minus. That means first one red, second one red. So there, since there are out of 10, there are three red, so it will be three out of three. This is not there. Three out of red times. Then you get remaining nine, so that will nine. And you both red, it means two. So you could do this way also, and this will be 6 by 90. And you multiply 90 here, divide 90, and you get 90 minus 6. So that will give you 84, and using the calculator, you'll get 0.93333, and I think that's what I will. Okay, and then this goes round it to 0.94. So almost the same, exactly the same that answer. Let's go to the next. Okay, so this is example number 9.2. The question is, are the two events independent? Now, what is the meaning of two events A and B are independent means the probability of this B occurring is not affected by what has happened here in the first place. So that means, let's see, what I mean is if a coin is tossed two times, so this is the coin is tossed. So the two events are, the first is head. Now, what are the chances that the first one, probability that it is heads? So it is going to be head is, it's going to be one out of two. And then second one is tossed. Now this also probability here, the second head, that means I'll just write this is second heads. So is also, it is one out of two, because when a coin is tossed, there are chances, the sample space is head and tail, so it has to be head. So it does not. So what I mean is, the second time head occurring has got nothing to do with what is the first one, whether this was tail or head, doesn't matter. So these are called independent events, and I hope that takes care. Next is an event. First one, it will rain in Tucson, and event two is it will rain in Phoenix. Okay. Now these two events are interconnected, is because Phoenix is close to easy in the same state of Arizona. So this is Arizona. Okay, and here Phoenix is here, Tucson is down. Of course, all the clouds are moving. Maybe if it rains in, it will rain in Tucson. So let's see if it rains in Tucson. If it rains here, then there is a possibility this also is going to rain, because of the first case. So raining in Tucson is affects the rain also, that is going to be raining in Phoenix. So this is Phoenix. So that's what that means. So this is not independent. Now what is the meaning of, so not independent also means dependent. So these are dependent event. And next question is, you draw a red card, then draw second card without replacement. The word without replacement is very important. So this is the deck of cards, and you pull one card here, first card, and then you pull the second card, because you're not replacing the first one. So this is taken out, but it stays out. And probability of the second card, this, whatever the card here, this depends. So here the, sec, the what the second card depends on what was the first card, because you have not replaced it back, right? So that's why we say these are again not independent. These are dependent again. So drawing the second card depends on what was the first card. Then D, coin is tossed and you record the head or tails. Again, coin is tossed and you record head or tail, and you roll a die, and then you roll a die. Now remember, whatever the whatever the number shows up on a while rolling a die is not affected by the coin, whatever the first coin is. So here, whether it is head or tail, it does not affect what is the probability of the second one. Let's see if it is showing what a probability of number showing greater than 4. And you can say it is 5 and 6, so it is 2 out of 6. See? So this number has nothing to do with what happened, whether it is head or tail here. Okay, let's take actual problems. Question number 9.3. A card is pulled out from a deck of cards and noted, and the card is then replaced. So if this is a deck of cards, a deck of card contains 52 cards, right? So when you pull out a one card, okay, and you take a note of this. So that means one card is kept here. This is the first card. So this is the first card, and you take a note of it. Okay, so it means you write down what is this card is, whatever that is, the ace card or queen card or a black card, a red card, and then after that you put it back again. When you put it back again, you are back to 52 cards, and then you pull the second card. So this is the second card. So, so the question is, uh, because you replace, so this is replaced, these two events are because you're back to 52 cards, and then you're picking the second card. So when you pick the second card, you are back to the remaining the all 52 cards. So picking the second card, probability of whatever this card will be does not have nothing to do with the first card. Why? Because you already put it back. So you are getting all your cards. Now, in this case, they also asked us what is the probability that both are aces. So let's call A1, the first card is the ace card. First card is ace, and A2, second card is ace. Okay, and what we wanted both are aces. So we will write probability that it is the first card is ace, and probability that the second card is also ace. Now, by using multiplication rule of probability, we write the probability of the first card is ace, times probability of uh, second card is ace card, knowing that the first card is already ace card. Okay, so that means the answer here is probability the first card is ace card. Since there are 52 cards, 52 cards. So out of 52, you're thinking of ace cards. So there are 4 ace cards, and then multiply by. Now, since you replace, so this probability of first card is 4 out of 52, and you replace it back, and then we pull out the second one. Remember, the second one is again this card is back to because you back to 52 card. That means this will be out of 52. And again, you have all 4 aces back here. So ace 1, ace 2, ace 3, ace 4. There are 4 aces, right? So, so no matter what this card, this is put back. So again, you have chances of getting 4 aces. So write 4 aces. Now 4 aces is also written as 1 out of 13 because 13 divide, okay, 4 divides 52. If you want, I can, so you divide by 4, divide by 4. Same thing, divide by 4, divide by 4. 1 over 13. And this is 1 over 169. And if you use the calculator, you can find also in the decimal. So I'll just leave it there and you're done. So what does this basically helps you to understand that multiplication rule of probability. And the main thing is here, the probability that the second is card is ace card, knowing that the first card is ace card is same as probability of A too. So that means see, it changes. So there is not, both are same. And I hope that makes sense to you to understand this. Okay, so again, last time I already explained to you what is the meaning of mutually exclusive event. So that means if A and B are two events, and there is nothing common between them. So this is like empty or it is just a blank. It means it could be a class of students where A stands for those who go for math tutoring and B is those who go for chemistry tutoring. And you can see there's nothing common here. It's not like how you overlapping where there could be some student taking A and B. So this does not work there. So these are called disjoint, and what is the meaning of disjoint? Basically means they are mutually exclusive event. So such case is called, and when you want to figure out the probability of A and B in such case is 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 there's nothing here, right? So it means no outcomes in this. So it's just a zero. So this is when it is mutually exclusive. So it means whatever, you're picking a student who is a mathematics, attending maths tutoring, has got nothing to do. Picking a student, he is a chemistry tutor going for tutoring. So they are not, they cannot. So no matter, so when you pick a student from, let's say, if I pick a student from a class, from this class, now either that student is a maths student, or he could be a chemist. He cannot be both. That's why it says here both cannot occur. See, if one occurs, the other one cannot. What is the meaning of independent events? Is occurrence of one does not affect probability of the other event. That means knowing one event happened does not change the likelihood of the other event. So for this is what I showed you the earlier class, earlier example, probability of both aces. The first one is ace and the second one is ace. See, so that's what this basically the formula is directly. So without, so what happened in B doesn't matter. It's as good as writing probability of A. So let's take an example of this. Okay, let's begin with exercise. Uh, First question. So for two events A and B, probability of A is given, probability of B is given, and probability of A and B. So the moment you see this piece, so I just want to show that. So A and B, there is some number, right? It's not zero. That means this is not empty. This is not empty. That means there is something there. So naturally, these are mutually not even the question did not. So these are not mutually exclusive. Okay. Then, but here the question is asked is what is probability of A and B? Now, by formula, what is probability of A? A when B occurred, this formula is it is conditional probability, that is probability of A and B divide. So let me write it right here. That would be more easier. A when B occurred is probability of A and B both occurring divide by probability of B. Okay, and then you work this out. A and B is given to you here. This goes right here, which is 0.29, and B will go right here, which is 0.48. And if you use the calculator, you get 0.604. So I'm going to write this is probability when B has occurred. So I'll put this in the box here. Okay, next is question number B says So B is, find this, right? So probability of B when A occurred is, again the same thing, probability of A and B divided by probability of A. So this is given, A and B is 0.29 and A is given to you is here 0.73. And if you do this, use the calculator, you get 397. So what did we do? This one is probability when B, probability of B happening when A has occurred, right? So this is a, and finally they're asking, are they independent or not? So how do we know they are independent or not is, let's see, probability of A when B happen, we know that this answer from here is 0.604, right? And probability of just a A, okay, just a A, and probability of just a A, here it is, just a here is 0.73, and you can see these two numbers are not same. So in other words, we say probability of A when B occurred is not same as probability of A. So that means we can say that A, B are not independent. And you're done. It means they are dependent. Independent, right? Okay. Another way to show also is you could do um, the multiplication rule. That means if this is same as probability of A and times probability of B, then we can say also they are independent. But if you see this, if I multiply A and B, A is 0.73, and if you multiply to 0.48, this will not be the same as A and B, which is 0.29. Okay, so I hope that takes care of this. Let's do another example. Question number 2. Again, same question, practice problem. I want you to pause the video and do it yourself. So again, they gave you the two probabilities and this, and find out this. I'm gonna go quickly. Probability of A and when B occurred is by conditional probability is a ratio. The B goes down, probability of B, and the top one is what is common, A and B. So that means this answer is A and B is 11, 0.11, and B is 0.37. Okay, and that will work out to be 0.297. Next is we'll do probability of B when A occur. So this answer is because then this time A will be down, probability of A, but the numerator stays the same, A and B. So this answer will be uh, the the numerator is the same, but probability of A is 0.26. So that gives you 0. That will so that will be 0.423. Next question is the C part. But are they independent? So how do we know this? They are independent is, so first of all, probability of A when, so the first one, this is the A part. I'm gonna write this probability of A when B occurred is 0.297, and probability of just a A, you can see here, this one is 0.26, and you can see these two pieces are not equal. They are not equal. So because they are not equal, so we can write probability of A when B occurred is not equal to probability of A. And that's why we can say A and B are not independent. I hope that takes care. Let's do another one. Okay, let's check this probability. Again, they give us three probability of A is given, B is given, A and B given. So the first question is probability of A when B is given is conditional probability says it's a ratio. B goes down. This is probability of A and B. So this is A and B is 0.15 and B is 0.6. Okay, so this will give you 0.25. Okay, uh, so A is done. Next, this is A. So B is probability of B when A occurred. Formula says probability of A and B divided by probability of A. So the numerator is the same, 0.15 divided by A is this one, 0.25. Okay, and that will give you 0.6. Next question is asked C, are they independent or not? Let's check this probability of A. Probability of A when B occurred is already this answer, 0.25. And if you see from here, probability of A is 0.25. And if you see, they are both equal. Both are same. And that's why we can say probability of A when B occurred is same as probability of A. So this satisfies the definition that what is the meaning of independent. So A and B are independent. I don't have enough room to write independent events. So this is how you write. And the fourth question is, are A and B mutually exclusive? And you can see this probability of A and B is zero, and this is a number. This is not zero, right? Only if it is zero, then we could say it is mutually exclusive. So that means in the event A and B, there is always something common here, and that's why. See this part, and this is so the so conclusion is this is not mutually exclusive. Okay, let's go to the next. Okay, so question number 5 says two coins are tossed. The moment you toss two coins, the first thing is you have a sample space, and it could be first head, second head and tail, or it could be tail first and second head and tail. So there are four options, four outcomes. These are four. Okay. The next question is what is the probability that the second is head, right? So that means we'll call this as A and say, okay, A is second is head. So that means it could be second head. That means first one uh, could be head or tail. See, so in both cases there is second is the head. So that means there are two of them. So the probability of this that the second head will be there because there are two. It is 2 out of 4 because you get it half. The next is so for me this is important is probability that the second is head given that the first is already heads. That means I'm gonna make this piece first is head. Let's call B as first head. So which are the ones that has first head? So head and head. That means you have first head or head and tail. So that means this means there are two of them. Okay. So the probability of B is here probability B is 2 out of 4. I'm gonna keep this number important. And next is but the question is asking what is the probability of second head. That means he's asking probability second head when you know it is B. It means it is the first one is already head. So that means by conditional probability is this divided by probability of B. But then what is that means we need to know what is probability A and B. So if you see in the sets of A and B, this is A. So A and B, what is that you common you see is H H first head, second head. This is the only one that is common. So that means it is one. So it is head. That means probability of this piece is A and B is 1 out of 4. So when I'm writing this answer, this will be 1 out of 4 divided by, and the B is this 2 out of 4. You can cross out 4 and you get half. And the last question is C is probability that second is head. That means probability again A means the second one is head, and they gave us at least one of the two tosses is heads. That means we can call another one C, which represents. So let's write C is at least one is head. Now, when I write at least one is head, it means C is head. That means here also there is one head or head tail. At least one of them should be head. So or tail head. There are three of them. See. So this is 3. That means probability of C is 3 here. And what is the common here? I'm gonna use green color to show the C, because when we want to write this will be probability of A and C and probability of C by conditional probability. So A and C, how do we find this? So we need to know what is A and C. So A and C, so A is here and C is here. We can see there are two of them common, which are the one head and head, so, and also tail in it, this one. So these two pieces are common. So that means there are two of them here. And that's why probability of A and C will be is 2 out of 4. So therefore, when you write the answer here, this will be A and C probability is 2 out of 4, and C probability of C is yeah, this is 3. So there are 3 here. See, C has 3, so it is 3 out of 4. So 4 crosses out, and you get 2 out of 4. You're done. Or we could use. Can we use? The question is, can we use for the second one, reduce sample space? So how do we use reduce sample spaces? Okay, reduce sample space as probability that second one is head. That means second is head when you already know the first one is head already. First one is head. So this means you want to check how many of these 4 pieces has got head first. And you can say these are the head, 2 of them. So that means it is out of 2. And how many of these has head second? And this is the head second, so directly you can do done. And the next one says probability of uh, second head. So second head when when at least one of the two tosses should be heads. So this means at least it is already being known that at least one of the two tosses is head. Okay, so what does this means? One of the two tosses is head. That's what we have to do, reducing the whole four of them. Which among them at least basically means uh, there has to be a head. So there's a head here, there's a head here, there's a head here. Three. So that out of three. And the second is head. And you can the second head is this and this. So it is two. Two out of three, and you're done. So this is question number 6. A deck of cards, card of 16 cards. So there are only 16 cards and 4 blue, 4 yellow, 4 green, and 4 red. So I'll try to draw quickly for blue. That means there are 4 cards which are 1, 2, 3, and 4. So those are like 1, 2, 3, and 4. Then there are 4 yellow cards. So that means I have to draw yellow. So 1, mm, 1, 2, 3, and 4. Then 4 red card. So I have to draw red card and 4 green. Okay. So all together total there are 16 cards. So that means the sample space, that means if you want to pick any card, it will be always out of 16 cards. Then let me use the number. This is 1, 2, 3, and 4. Each card is numbered 4, 1, 2, 3, and 4. The question says the 4 cards of each color are numbered from 1 to 4. A single card is drawn. So one card is drawn. So the question is find the probability. The first question is what is the probability that the card is red? Now that means we already know there are total 16 cards. So this answer has to be out of 16 because there are 16 cards. and the and how many are red cards? So what is the how many outcomes are there that are favorable to red? So the red cards are 1, 2, 3, and 4. It means 4 out of 16. So that means the answer is, which you can keep 4 out of 16, but I'll just reduce it by dividing by 4. 4 divides 4 once, and 4 divides 16 4 times. So the answer is 1/4. Let's redo B. What B says, find the probability that the card is red. So I'm going to write probability that the card is going to be red card. So it is going to be red card, knowing that it's been given to you that the card is not green. That means when you pull out the card, let's say this card is not green. So what is the meaning of not green? Basically means the rest of the other non-green cards. So that means so this is I will write not green. So let's write not green. So let's use the reduce sample space is that means out when you that means you already know it is not green. If it is not green, that means if it is if the card is, let's see, this is not the card, that means the remaining cards are 12. See, so that means there are 12 cards and you want to pick you want to have a red card. So the red cards are again there are 4 of this. See, these are 4 reds, so this is 4 out of 12. If we divide by 4 the numerator and denominator, you get 1/3. Then the question number C says probability card is red. So again, it's going to be red card, but it is given that it is neither yellow nor neither. So, so I will say not. So that if it is being told to us, it is not red and it is not yellow also, not yellow. So that means your ratio, the denominator. So which are the cards which are not not red and not so if I so that means I will have to cross out the cards that are not red. That means all these are cancelled and not yellow. That means remaining is eight are there so out of eight. And the card has what is the chances that it's going to be a red card? But since the card selected itself is not red, so if this is itself is not red, how can the card be a red card? So the numerator is zero because it is already told to us it's not a red card, and you want to say it's a red card. So that's not possible. So we say this answer is zero. Okay, and finally, the last question is chances that the card is red. Again, probability that it is a red card, and it is told to it is not four. And I have to cancel this four cards. See? So that means these are remaining 12. So out of 12, I'm going to say not four, not four. That means out of 12. How many are red? And you can see there are four red. So it is 4 out of 12. So divide by 4, you get 1 out of 3, and you're done. So let's go to question number 7. Now, I don't have the visuals. Let's do directly this question. They have the same question. You have a 4 blue, 4 yellow, 4 green, and 4 red. So there are 16 cards. 4 cards are picked. Everything is the same. But this time the question is asking what is the probability that card drawn is 2 or 4? So either it is 2 or 4. That means if I have this card, these are 1 1 1 1 1 1 1 card, okay, and these are I think it is better to draw to understand. These are 2 2 2 2 2 cards, and these are 3 3 3 cards. The question is what is the probability? Either it is 2 or 4. When you pull out of the 16, when you pull out one card, so that means the card that you're going to pull is either it has to be 2 or it has to be 4. So that means we can, which are the cards? 2 cards. So these are 2 cards. How many are there? 4. And there are 4 card of 4. So there are 4 with number 4. 8. So this answer becomes out of 8. Out of 16. So there are 16 altogether, and you're picking either 2 or 4. So the total is 2, 4, 4 plus 4 is there are 8 cards, and that answer is half. You can also use addition rule of probability that it is uh, either 2 or 4. That means it is 2 or 4. Basically means probability is 2 plus probability of 4 and probability of 2 and 4. And means this, you see. Probability of 2, there are 4 out of 16, plus there are 4 cards out of 4 cards of 4, 16. And there are a card cannot be both 2 and 4. This is 0 out of 16. So you still get 8 out of 16, the same answer. Now the next question, find the probability that the card is 2 or 4. It's told to it is not 1. So if it is not 1, it means I have to take away this one. See, that means there will be only 12 left. So question number B says this B is probability that it is 2 or 4 given that it's not 1. See, that means not 1 means there are already 12 cards because this is gone. So this part is gone. So that means there are 12 remaining, and number of cards that has 2 and 4 is again the same. So it is these two which are 4 and this 4 which are again another 4. So you get 8 out of 12. And if you divide by 4 both, you get 2 out of 3. And C is 2 or 4, and it is told why it is either 2 or 3. That means the card is, let me take this off. So the card is, it is given to us that the card is 2 or 3. That means the card that you have drawn, either it is 2 or it is 3. So how many? So that means probability that you're going to get 2 or 4, and it is told to us, it is already told either it is 2 or 3. So how many cards are 2 or 3? It means 2 is this and 3 is this. So there are 8. And how many among this is 2 and 4? 2 or 4. And you can see the 2 is what is there inside, and there are 4 of them. So 4 out of 8, and you get half. And the last question is D. D says probability that the card is again the same question, all of them. Probability it is 2 or 4, but it is told to us that the card is red or green. So let's see, red or green means, let's see, this is red and these are all green cards. So these are all red and the other one are green. So that means there are 8 of them. See, red cards are, so this answer is out of 8 because that's the reduced sample space. And you want to have 2 or 4, and among this 2 and 4 will be this 2 and this 4. So that means there are 4 cards, 4 out of 8, which is half, and you're done. So question number 8 is, you are given a two-way table, two rows and 2 columns. So in this experiment, it is two-way contingency table. Use the probabilities. All the probabilities are given. What this means is probability that A is 0.1. Actually, probability of A and R is, this one is probability of A and R. This is probability of A and S. But if I want to find a total here of this, if I want to know what is probability of A, it is this, you have to add 0.18. So that becomes 0.3 this way. So let's see what question, based on the question, we'll try to solve this. First question is, what is oh yeah. So what is probability of A? The first A is, probability of A is, we'll have to add this way. See, it's like I can make a one more column here to show. That means this is, you are adding 0.12 plus 0.18, and if you add, you get 0.3. So that's 0.3. So you can write this. This is 0.3. Okay. Now what is probability of B? Just a, sorry, probability of R. So probability R will be, you'll have to add this way. That means this total here. So this is what we have to fill up here, this one. So R will be this 12 plus this 0.8, and you get 0.40. And the next question is asking what is probability of A and R, and that is the one that is for both. Yeah. So that means, so this will be A and R. So that means this one, 0.12, which is common. So that is 0.12. And based on this question based on question number A, are these A and R independent? So the question is asked, is this independent? Question number B says, how do we know something is independent? Is So best way to check this is you have to know by multiplication probability A and R. So we have to say whether this is really probability of A times probability R. If we can prove this, we are done. And the reason is the multiplication probability says probability, let's see if it is A and R. Actually, the formula is probability of the first one times probability of the second one when you know that the first one has occurred. But if I say independent, basically means occurring of, that means occurring of A, that means whatever A probability does not affect the chances to get R, and that's why I say this answer is probability of R. So this whole thing reduces to is probability of R, and that's why this is a formula which changes to this formula. Now let's see what is probability of A and R. So A and R is 0.12. There it is. See? Equals. Now let's see what is probability of A. We got here 30, 0.3 multiplied by, and R is we got 0. So this is 0.40. Okay, and if we multiply this, you get 4 times 3 is 12, and you see it becomes 0. This, and it is the same answer. So this answer, that is whatever that you get here, so the left side and the right side is the same. So this is correct. So this rule, so this formula really works. The multiplication rule of probability, which is reduced to if two events are independent, and this has to hold, and this is true. So we say yes. So the question is yes, A and R are independent events. Okay, the next question is asked based on this, check whether or not APR can be predicted without any computation. Okay, the third question, number C, says based on answer B, that means we know that A and R are independent. Can we determine what is whether or not can we figure out this without doing any calculations? Now, APR, so let's write this. Because A and R are already independent, that means this probability of A does not get affected by what R has occurred. So that means this is same as probability of A. So whatever probability A is, it will be this. And probability of A that we have found on top here, this is 0.3. So this is 0.3. And probability of A when R occurs. So without computing, we can directly say, or we could use conditional probability. What is that? Probability of A when R has occurred is probability of A and R. This is by conditional probability divided by probability of R. Now A and R, this from the table, A and R, let me show this. So this one, A and R is this one. See? So 0.12. And R is right here. This is the total of these two. This together is, that's what I'm saying is, so this together is is 0.40. That is probably R, so it is 0.40. And if you do the little maths there, if you do this, which is same as 12 out of 4, I mean, zero point 0.2 out of 4, and sorry, this will be gives you back to the same answer. 4 goes, uh, it means, sorry. So this is calculator does the job, but I was trying to do without the calculator is 12 out of 40. See, so which is same as 1.2 divided by 4, and that is 0.3. See, so that's what the answer is. I hope I made sense to you guys. Let's go question number 9. Question number 9, a again you have a two-way contingency table, and you are supposed, and they give you the whole table can be seen. Find P of A. So let's start with A. P of A. That means you are adding these two. It is, if you add the calculator, 13, and that will give you 3 and 1, 0.20. See? So first question is done. So this actually, this is what it is actually. This is 0.20. You're adding those things. And the question A has itself has 3, so PR, so probability of R, you're adding this one, right? So that will give you 13 and 61 will give you 0.74. So this is 0 point, so this part 0.74. Okay. Now and then last one, what is P and R? So P of A and R is what is common. See, this is what is common for A and for R, which is 0.13. Now we want to know whether this A R are independent, right? Same idea. In other words, this is already given to you. Let's just figure out what is this is B part. Multiply probability of A times probability of R. So this A is this one, which is 0.20, and you are multiplying to R. R is this one, 0.74, and you use the calculator 0.20 and you get 0.148. So, but then you notice that this number and this number is not the same. So 0.113 is not same as 0.148. What we learned is probability of A and R is not same as probability of A times probability of R. So what that basically means, A and R are not independent, are not, it means they are dependent also, so they are not independent. It means A and R are dependent. Okay, that was the question. Now here the question says, uh, based on the answer that we got, like now that we know that A and R are not independent, so we know that A and R, what that basically means, what that means is probability of A when A has occurred, okay, is cannot be same as probability of A. So that means A is getting affected by R. So the chances for A occurring depends on this R. So we cannot predict this. So we cannot predict directly without just because by just looking at it. We could have predicted that if it was equal. Remember, if they were independent, if this were independent, then we could say that this would be same, and we could just say without calculation. But right now they are not equal. That means chances of A happening depends on what is R. So we have to use conditional probability here. So, so what is the conditional probability is? Probability of A and R occurring divided by probability of R. And just plug in the values. R, where is R? R is here. So R is 0.74. And what is common there is A and R. This is common, which is 0.13. And if you use if you use the calculator, you get 0.176 and you're done. Hope that helps. Question number 9. Let's do question number 10. Question number 10 says, suppose events A and B are given and you have given probability of A and B and you are supposed to explain why there is not enough. Either you compute the indicated probabilities or you can say there is no enough information to do so. Now, so first question is what is probability of A? So can we figure out probability of A and B? Now, based on this information, it just gives us probability of A and B. There's no information says, it does not tell us whether they are independent. Okay, so because they are, if they did not tell us independent and you cannot find this, so it means this is probability of A by using multiplication rule of probability, but you don't know this. So we don't know when A has occurred, what is B. So we have for this question we say there is no. So we can say there is no enough. There is no enough information. But if you see the second question says there is information, extra information. They are independent. Now, what is the meaning of independent? It means probability of B when A occurred is same as probability of B. So what this basically means, the formula probability of A and B is directly becomes probability of A times chances of B. So I'm instead of probability, I use that word chances because probability, like there are five uh, ways. Chances is just two chances too. So that comes here. So chances of A and B is, so we can write A is given because they are independent. This is correct. And A is given to is 0.70 and B is given to is 0.3. And if you multiply, you get 0.21 and you're done. Then there is that one more information says what is chances of A and B both occurring when information is that A and B are mutually exclusive. So this answer A and B, what is mutually exclusive means A and B, if you check the Venn diagram, they don't have nothing common. It's not like they are overlapping. So this would be A and B. So here they are disjoint. They don't have no outcomes common here. And that's why it is like 0. So this probability of A and B happening is 0. And that's it. You're done. I hope that helps. So there is a, if two events are mutually exclusive, see, when you say mutually exclusive, means they cannot both occur at the same time. This means their intersection is empty, which I showed here, and the probability of the intersection is 0. So question number 11 also is the same. You can pause the video, do it by yourself, and then check. Suppose these are A and B are connected to some experiment, and this is given to you in A and B. So let's see, suppose I want to find probability of A. Are we able to figure out like last question, same thing, we don't have no enough information. We don't know. We cannot do this. So this is no enough information. And if you see the next question says they are independent. Now what is the meaning of independent? Probability of A and B is probability of A times chances that B occurs. So this is the formula. So all you do is just put this here and this here, which is 0.50 times 0.5. 5 times 5 is 25, 0.25. This is probability of A and B. The next question says, Find this if they gave us that they are both A and B are mutually exclusive. So what is the meaning of mutually exclusive means? Again, the same thing, A, B are disjoint. A and B do not have no common outcomes. It means, it basically means both A and B cannot occur at the same time. So this answer is 0. Yet another given two-way contingency. The breakdown is already given. The population of patrons at a grocery store according to the number of items purchased and whether or not the patron made an impulse purchase at the checkout or not. So impulse purchase basically means like on the spot, spontaneous. So the number of items is given few items and many items. And this one says with impulse, they spontaneously made a decision. And this one took time, not made impulse. So they gave you the probability. So the question is, I wanted to read and comprehend this because I'm making this video. There's no enough time to do everything. So patron is selected. Okay, and the question is find the probability that the patron made a impulsive purchase. So when I say impulsive purchase, basically means this one. This is the impulsive purchase. So probability means I'll write impulsive purchase. So this answer will be you'll have to add this to and you get 0.01 plus 0.04, you get 0.05. So that's the thing. The next question is asking us is so the question here is, first one is done, and the second question is saying B. Patron made an impulsive purchase, so I'm gonna use impulsive purchase. Given that the total number of item purchased were many, so this could be I could write many, and these are few. We can write this is I impulsive purchase, and the other one is I not N M not impulsive purchase. Because the question is asked, given that the number of items was many, that means probability that impulsive, that means on the spot, the buyer or patron bought, and it is being told to you that the total number of items were many. Many means I'll put M here. Now we have to use conditional probability. What is that? Probability that impulsive purchase and many divide by probability of many. So that means we have to from the table, so here the table clearly shows. So what is that common here? Impulsive, this is I am. So let's call this as I am. And this is not I am. I think that's another way to write, not impulsive. So bottom part is many purchase means we'll have to add this to, that means 0.4. I think I should have done this first. So the bottom part is 0.04 plus. So many is 0.04 and 0.76. If you add, it becomes 0.80. So this is at 0.80 here. So the bottom piece becomes 0.8. And this answer is what is that common for many? So you have to go for, let me show this piece and impulsive, this one. So this is the total. This is the number. So you get 0.0. Okay, sorry, 0.04, and that is 0.05. Check with the calculator. The last question is determine whether or not few purchases and made an impulsive purchase of a check. Are they independent? What is asking is few purchases is F, probability of F, and made impulsive means I, and I, is this really equal to probability of few purchases times probability of I. So if you see this, F and I, so this is 0.4, which is, sorry, not that. So this, let me take this off. Uh, few and impulses is 0.1. So that's like 0.1. So this is 0.01. And probability of few was together this piece. That is, I think I did this. We'll be adding this to will be 0.20, and impulsive. So impulsive will be together. This is the impulsive, right? So this becomes total of these two is 0.05. So that means 0.0. Now this is, when I say this means it is I am impulsive purchase. Then when you multiply these two, you get 0.01. And you can see this is 0.01 and this multiplication also is same. And that's why we can say few purchases F and impulsive purchase, they are both are independent. What basically means if you buy few purchases does not affect your impulsive. That's what it means, impulsive purchase. So that's what it means. Just because you are buying few purchases, you make a spontaneous decision to buy? No, it doesn't have nothing to do. That's what it is. So it's independent. Let's go third. Question number 13 is saying a sensitivity of a drug, also known as its true positive rate, is the probability that the test correctly returns a positive result for a person who has actually drug. That means if this person is suffering from drug and he takes the test, he goes to the test and then he comes out, and the chances that he's going to be probability, so P1, the first, it means there are two clinics. This is clinic 1, this is clinic 1, and this is another one, clinic 2. 1 and 2 both have got chances that a person who has drug and they go to do the test, he goes here and he goes here. The probability in the maybe he goes to the test to the first one, that he's going to be positive is given to you as 0.75. That means what does this means is probability that he will be negative. So this is negative, right? And negative means not positive. So when I say this is when the test will be positive. If the test is negative, that means you write complement of this. So that means it's just one minus the other one. So if I say T1 be let T1 and T1 be the event that the first test is positive. The first test is positive. Okay. So the chances that, so if T1 is stands for first test is positive, then chances probability that it's going to be positive is this one. And chances that it's not going to be positive will be 1 minus. So if you subtract from 1 and 0.75, you get 0.25. Then that means the patient, whoever the person, this guy, he can get away with the undetected. So that will be 0.25, 25%. In the first case. In this one, it says probability that T2 stands for the second test is positive. T2 is an event that the second test is positive. That means chances that he will be tested positive. Here is given to you as 0.85. That means he can get away with the test which it says complement means he test negative. That means this one tests negative. This means tests positive. So it's better to know. So this answer is if I take away 1 minus, of course, this is almost like 85%, right? So that means negative will be 15%, common sense, which will be 0.15. If you use the calculator, you can do 1 minus, same thing what I did, like this, 1 minus can do here. So these are the two things which are important. This and this and this two. And the question is, if both are applied to an athlete, I mean, this guy, he goes to this clinic and this clinic. Uh, he said, what is the chance that their usage will be undetected? In other words, probability that he tests negative in both cases. So that means he tests negative in the first one and he tests negative in the second one also. That's what this creepy form symbols means. It means probability of t of this times because they are independent. You know why they are independent is test done in the first clinic has got nothing to do with the test done in the second clinic. This one does not get affected what's happening here, and that's why we can multiply directly. They are independent events. So we just multiply. This goes right here, which is 0.25, and this goes here. And if you multiply this, you get 0.0375. Means like almost like 3.75%. Very small. Okay, let's go to 14.